All right, at this point, you have earlier in the course, we've covered the core concepts and abstractions of what Service Fabric provides to you. And we talked about how you can build guest executables that Service Fabric can then just take your code and deploy it throughout the cluster. In this section now, we're going to start talking about reliable services. Reliable services is now the introduction of using Service Fabric's own programming models. And by adopting these programming models, you gain some additional features. So if you look at this slide here, reliable services come in two different flavors, stateless and stateful. In this part of the course, we're going to be focusing on stateless. Right now, our programming models are .NET only programming models. So you have to write in C# or VB or some other .NET language in order to take advantage of these. If you adopt our programming model, then the features that you get is some better networking naming service support. That is, you can have in your service a bunch of endpoints that you wish to expose, and then those endpoints can be returned by your service to the Service Fabric runtime, and you can go and publish them in the naming service so that clients can discover the endpoints of your service and then talk to your service directly with high performance. Another feature is the one I just mentioned at the end of the previous part of this course, which was the self-reporting of the instance's load metrics. With that, your service can periodically call a method as it's running to say, I'm using 50 gigabytes of the disk, now 60 gigabytes, 70 gigabytes, and so on, and Service Fabric takes that into account in order to rebalance the service instances throughout the cluster. With our programming model, you can integrate with code, configuration, and data upgrades, so that when Service Fabric wants to upgrade your application, which we talked about in an earlier part of the course, Service Fabric will now notify your service instance that it wants to upgrade you. And then your instance can maybe complete processing some client requests or maybe flush some data that it has in memory out to disk somewhere before your service instance is brought down and the upgrade then continues. This allows you to have more coordination over the upgrades. When your code is upgrading, I didn't mention earlier in the course, but Service Fabric also allows in addition to code packages, it has configuration packages and it has data packages that are available for your service types. And you're allowed to upgrade any of these three things, code, configure, data, independently of the other things. Each one would have a version number on it, and you'd have to do all the versioning stuff I mentioned earlier in the course. I also mentioned earlier in the course that when you're using our programming models, since they are .NET, you have better efficiency or higher density, if you will. Because instead of running each of your instances in a separate process on a node, instead Service Fabric will just go and create a different .NET object for each of the instances or replicas. And that uses much less memory than a Windows process does. Now, on top of a reliable services programming model, other programming models can be built. And in fact, Service Fabric does ship another programming model called reliable actors, which I don't cover in this course, but you can research that and use it if you'd like to. But it is built on top of a lot of the infrastructure that I will be talking about here. Now, if you are familiar with Azure Cloud Services, our reliable services programming model for Service Fabric is quite similar. Just like you would with Azure Cloud Services, you would have a class that derives off of a base class called role entry point. And role entry point has three virtual methods on it: on, stop, run, and on start. Our base class in Service Fabric is very similar. We have a base class called Stateless Service, or if you're doing a stateful service, we have one called Stateful Service. And instead of having on start and on stop methods, those go away. And instead of having run, we have another method called run async. And our run async method takes a cancellation token as an argument, and that's what we signal to let you know when we want your service instance or replica to come down. So basically, when we want to start you, we just call run async, and you can do whatever initialization in there you want. Then your run async would just continue running, usually looping around in an infinite loop, and periodically checking the cancellation token. And instead of us calling on stop, like you would with a cloud service, we will go and set the cancellation token. That lets you know that the loop should stop, and then you could execute whatever cleanup code you want to, and then you return from run async. We know your instance is done, and then we can now begin to do the upgrade or move your instance to another node in the cluster or whatever it is we need to do. So it's really very simple. We have this one virtual method on our base class called run async, which is the real workhorse. Now, your services typically do one of two things, or possibly they do both. but usually they do one or the other. And typically what your service does is it can go and create some listeners, like an HTTP listener or a TCP listener, and then it is listening for network requests to come into the service. And then when the network requests come in, they do their processing and they return results. The other thing your service could do is, instead of having any listeners at all, it could be polling a queue to pull messages out of it and then process those messages. And of course, a service could do both. You could have listeners, and you could also be pulling messages from a queue or grabbing some data from some data source like a queue. And you can do whatever you want to in any of these services. If you are building stateless services, then you will probably have some additional state that you want to store somewhere in some kind of external storage service. If you're running in Azure, then the common scenarios are to put your data in Azure Storage or SQL database, or to use DocumentDB. But of course, there's many storage services that are around today, things like Mongo and Cassandra and so on, and all of these are available. If your data is so large that it can't fit in a single location, then you would have to partition that data. And all I'm saying by this last bullet on the slide here is that you just have to make sure that you partition your data so it scales well. This is actually independent of using Service Fabric or not. This is something you just have to do no matter what. Okay, at this point, we're going to pause, and I'll come back with a demo where I will walk you through in Visual Studio how to create your first stateless reliable service, and I will show you what the code looks like that you can start integrating your own code into it.